Hi guys, I'm Brian Snyder, the CSIO of A.R.T Digital, here today at the Force Physics Laboratory in Scottsdale, Arizona, and I'm here to talk to you about a breakthrough in thermal management technology. One of the big challenges miners have faced, and the semiconductor industry in general, is heat challenges. As we get smaller and smaller in our nodes and we build more and more efficient chips, there's a major problem that's occurring right now in this world, which is cooling technology. So Bitcoin mining has always been at the forefront of adopting to this technology. If you look at immersion systems, if you look at hydro systems, those systems have been on the forefront. The adoption rate for novel technologies when it comes to heat mitigation processes in an extremely demanding environment like Bitcoin mining, we have been presented with those challenges and are first to market to remove this. In front of me here, what I'm going to be showing you in the lab is a hydro board. This is an S19 hydro by Bitmain. As you can see in terms of the alignment, this is designed to be utilized with water block technology. So this is a water block here. We typically will have water flowing through in one side, out the other, to dissipate the heat. Standard function of hydro mining. What I'm here to show you today is actually an innovation in terms of a heat sink that manipulates airflow in such a way to maximize heat extraction. So let me dive into this a little bit further. So let's take a look at this modified S19 hydro board. This is a single board with multiple heat sinks on it instead of a water block. Air is being drawn through each one of those individual heat sinks through the duct, which is hooked to a blower, which is extracting the heat. It's pulling the heat out of the unit as opposed to forcing air through the miner. So here's the actual information on the miner itself. Right now, we're running Vanish software to test and push the ASICs to the limit. On the dashboard here, we see a single S19 Pro Plus Hydro board, which typically runs at 191 terahash with 3 boards. And it's running at approximately 57 terahash, about what we would expect at those clock settings. In previous experiments, we've actually run outside in Phoenix, Arizona, where we've actually intook 105 degree air, and we were still able to maintain stable ASIC temperatures. We've also practiced overclocking this board, and we were able to achieve approximately 83 terahash, about a 25% overclock with nominal temperatures. So what are we looking to achieve with this system? Well, on top of performance increases, in regards to being able to keep the chips cool at hotter temperature, we're trying to solve some major problems. Some of those problems include access to water. Current systems, evaporative systems, utilize water, can sometimes damage the equipment, and also water is not a always commonly available and ready resource. And on top of that, we're looking to reduce waste. A typical Bitcoin mining container at 1 megawatt will use between 300,000 to 400,000 CFM. These systems, with a blower and a high pressure system, will utilize substantially less, about 60,000 to 80,000 CFM per megawatt in equivalents. This reduction directly correlates into energy efficiency, which means less energy is required to drive all the individual fans on the ASICs, as opposed to a large, single, more power-efficient blower to move the air through the system. This achieves substantial gains in terms of electricity. More electricity is being used to go directly into the ASIC and the chip to do the math calculations to Bitcoin mine, as opposed to keeping the system cool. On top of this, it expands the operational envelope of this equipment. Right now, there's a lot of power resources that are available in the Middle East, but the temperatures there are so high that a good chunk of the year, especially over the summer months, those machines have to be scaled back, either in the low power mode to be able to accommodate the higher requirements, or shut down completely to avoid overheating and damaging the equipment. Utilizing this technology will allow us to run and operate within those environments where either other technologies, such as water block technology like the S19 Hydra, or immersion-based technologies cannot simply achieve. Reason why? Delta T. They can't exchange heat quickly enough through a fluid medium compared to this technology. At A.R.T Digital, we're passionate about redefining the future of Bitcoin mining and thermal management technology. If you're as excited as we are about these groundbreaking innovations, we'd love to hear from you. Whether you're looking to learn more, collaborate, or invest, feel free to reach out to us, social@artdigitalcorp.com. Let's innovate together.